Okay, everybody, welcome to the flipped class. I am, wait for it, Mr. Quick. All right, let's get started. Today we are talking about estimating with whole numbers. When you estimate, you don't need the exact answer. You can estimate and actually get an answer that is close enough to the actual answer. Sometimes we'll use compatible numbers. That's when you round numbers in the problem to make mental math easier when estimating. If you overestimate, that means your estimate is too high. If you underestimate, that means the estimate is too low. Okay, let's get into some examples. But first, let's take a little brain break, shall we? All right, do you see anything in these logos besides just a classic logo telling you what it is? If you saw that Baskin-Robbins has the number 31 for their famous 31 flavors of ice cream, then you totally nailed it. That's awesome. Congratulations to you. If you see in the Tour de France, which is of course a bicycle race, that you have a bicycle here and you have a rider here, very good. Pretty cool, huh? Okay, let's keep going. All right, first let's do a little rounding review. I want you to round the number 452,316 to the nearest 100,000. This is a little trick that I like to use, and it might help you remember when you're using rounding as well. The digit that we're going to be looking at is the 100,000s place, okay? Now we know we have ones, tens, hundreds, thousands, 10,000s, and 100,000s. So I'm going to go ahead and underline the digit that I'm going to be looking at, which is in the 100,000s place. The digit to the right, I'm going to circle and actually make that a little bit of a Q, because that is my bossy Q. Think about it this way. Who's the boss in class? Who is bossy, bossy, bossy sometimes? Well, Mr. Quick. My name starts with a Q. I'm the boss. In a rounding question or rounding problem, you want to look at the bossy Q to see which way you're going to go. If it is 1, 2, 3, 4, or 0, I'm going to put an X over all of those because the number stays the same. If it is 5, 6, 7, 8, or 9, I'm going to use an arrow because the number that we're looking at, the underlying number, goes up. Since this is a 5, and on my little chart here, my 5 is pointing up, this 4 actually turns into a 5, and then the bossy Q and all the numbers to the right all turn to zeros. So 452,316 to the nearest 100,000 actually rounds to 500,000. Pretty cool, okay? Let's move on. When you are estimating a sum or a difference by rounding, there's a few things that you can do. We're going to look at a sum in this problem because we have an addition problem. 5,439 plus 7,516. Well, let's take a look. First, we have to know what we're going to round it to. It doesn't make a whole lot of sense to round it to the nearest 10 or the nearest 1. That's not going to make it very easy for us to do the problem. The whole point of estimating is to make it easier for us to do the mental math. So we're going to go ahead and round it to the nearest thousands place, which means the hundreds place will be our bossy Q. In 5,439, 4 would tell us that the 5 stays the same, and of course these other 3 digits turn into zeros. So we have 5,000. And then in this number over here, we actually have a 5, which tells us that the 7 goes up to 8, and then the other digits stay the same. So instead of having to find an actual exact answer to 5,439 plus 7,516, instead we have a much easier problem, 5,000 plus 8,000, which of course is 13,000. That is our answer. It's not the exact answer, but I didn't ask you for an exact answer. I asked you for an estimate. So that's your answer for that. Now, if we're trying to find the difference, if we're trying to find the answer to a subtraction problem, here I've given you 62,167 minus 47,511. Okay? If it made sense to round it to a digit besides the 10,000s place, we would do it, but it doesn't. So in this case, we're going to round to the 10,000s place. That makes our 1,000 place value the bossy Q. That bossy Q that's going to tell our other digit what to do. In 62,167, the Q tells the 6 to stay the same. So we have a 6, and then all the other digits become zeros. So we end up with 60,000. Over here we have 47,511. This 7 actually tells the 4 to go up. So it becomes a 5, and then all the other digits still turn to zeros. So instead of a little bit of a harder problem, 62,167 minus 47,511, we're just estimating. We'll look at 60,000 minus 50,000, which of course gives us 10,000 for our estimate. Okay, that is our estimate. Let's keep rolling. A couple more logos to show you. All right. In Tostitos, they make awesome dip. They make awesome salsa. Well, guess what? There's 2 people right here dipping a chip in a bowl of salsa. You see it? There's one person. There's another person. There's the chip. There's the bowl. And there's a little table for them to stand on. Pretty sweet, huh? Also in the Amazon.com, and I love to use Amazon, there is a hidden message. Amazon.com. Everything from A to Z with a smile. And of course you have a little smiley face there. Pretty sweet. Let's move on. Okay, 9 times 27. We're estimating a product by rounding. Now, I don't need to round the 9. I'm only going to round the 27. And I'm going to round it to the nearest tens place. Okay? In the tens place is the 2, so this obviously represents 20. My bossy Q is the 7, which is in the ones place. That 7 tells the 2 to go up. So it turns into a 3. My 7 turns into a 0. So now I've got 9 times 30. And we know an easy way to do it is to look at it like this. 9 times 3 is 27. I've got one more 0 to bring down. So my estimate is 270. Now, is that an overestimate or an underestimate? Well, since we actually multiplied it by a higher number, we've actually overestimated. We've overestimated. Because 9 times 27 would actually be less than 9 times 30. So the actual answer would be less than 270. So in this case, we actually did overestimate the answer. We made it a little bit higher than it needed to be. Okay, estimating a quotient with compatible numbers. Okay, I'm going to read you this question. You can read it as well. Mrs. Bird will drive 120 miles to take Becca to the state fair. She can drive 65 miles per hour. About how long will that trip take? Okay, I want to point something out to you. Does this question tell us that we need to estimate? Does it say you need to estimate? I don't see it. But they do give us a big-time clue in which they actually are asking us to estimate, to use our estimating skills, okay? About how long. It didn't say exactly how long, okay? It didn't say, tell me exactly how long it will take. It said, about how long do you think it'll take, okay? She's going to go 120 miles. We're going to divide that by the 65 miles an hour that she's actually going to drive. Now, that's not the hardest question in the world, but we're not going to get an exact even answer, okay? So we can make this a little bit easier by using compatible numbers. First thing I see, 12 and 6. Well, that makes it really easy, right? We all know 12 divided by 6. So I'm going to look at it as 120, and I'm actually going to take the 65. Now, I'm not rounding now. I'm using compatible numbers. It's different. If I was rounding it, I'd have to round it to 70, but that doesn't make it easier. I'm going to make it into 60. I've got 12 divided by 6, which is 2. Zeros cancel each other out. About how long will her trip take? About 2 hours. Now, we have underestimated the speed. Okay? She can actually drive faster than that. because we underestimated the speed, her actual time would be less than 2 hours. Because we're pretending, just to make the math easier for us, that she's only going to drive 60 miles an hour. She's actually going to go faster than that. She'll actually go 65 miles an hour. So she'll get there a little bit quicker than 2 hours. But again, that's why we are estimating and not finding the exact answer. Okay, last brain break. The FedEx logo here. You see anything weird about it? You see anything unusual about it? I got to admit, I didn't see this for a long time. And when I did see it, my mind was blown. It was amazing. Okay, FedEx, obviously they want you to think that they're going to deliver your products very quickly, okay? So they've got to have a little bit of motion in their logo. And guess what? They do. They're always moving forward. So the space between the E and the X in FedEx, fill it in there, is an arrow pointing forward, okay? Pretty cool, huh? All right, this is the last slide. I've got a couple of quick questions for you. And since I don't have anything on this slide, I'm going to draw a picture. Hey, look, it's Mr. Quick. I don't know why I'm frowning. What can I do about that? Let's see here. Never mind. Let's do this. Let's make him happy. Let's make him happy. Okay, cool. All right. Suppose you're going to buy items for a dinner party. You have $50. Would it be better to overestimate or underestimate the cost of the items you're going to buy? Okay, think about it. I'm going to tell you it'd be better to overestimate. That way you'll be sure that you have enough money to buy everything. If you underestimate and it costs more than $50, when you go to check out, you're going to be out of luck. You're not going to have enough money. Okay? Second question. And since there's nothing to look at here, I'm going to draw another drawing of Mr. Quick. Even happier. Look. Teeth. Teeth. He's very happy. He's smiling so much he's showing his teeth. It's amazing. Okay. Second question. Suppose that your car can travel between 20 and 25 miles on 1 gallon of gas. You want to go on a 100-mile trip. Would it be better to overestimate or underestimate the number of miles per gallon that your car can travel? Think about it. Think about it. Would you over or underestimate? I'll tell you what I would do. I would underestimate the number of miles per gallon that the car can travel. Because if you overestimate it, guess what? You're going to look like this. Oh. There's my little car. And it's smoking because it's out of gas. And now Mr. Quick, who is in the car, is very angry. Yeah, so you want to underestimate the number of miles per gallon that your car can travel, because then you'll always make sure that you have enough gas in your car to get where you need to go. Okay, that's all I have for right now. I will see you tomorrow.